So this is an important definition that we want to formally define. So an axiom, I think I've used this word a few times in this class. What is an axiom? So an axiom is a statement that cannot be proven to be true. So this is something that it says it must be accepted by faith that it is true. We do not have the ability to prove something. So this was when we look back at the piano arithmetic or piano axioms of the natural numbers. We couldn't prove these natural numbers. We just accept by faith that these natural numbers exist. There's and so Geometry is a big one. Geometry has a lot of axioms. So that's actually something that's a little bit different, where the axioms for geometry are going to be different than the axioms of set theory, where most of the number sense, most of the functions, sets, everything we've done, all of that's based off of these set theory things, but geometry has its own axioms. And then that leads to a whole wild and crazy thing. If you study the axioms of geometry, whoo, it's a lot of fun. So kudos to you who are in modern geometry getting to delve into some of that. But nonetheless, an axiom, that's what we have. So in 1901, we have Russell's paradox that said, wait a minute, the set of all sets doesn't make sense. Sets kind of stink. How do we fix them? So then in 1908, Zermelo, this mathematician, Zermelo came along and he created an axiomatic system for sets. And so what this means is that we have now these statements that every single thing that we're going to do moving forward mathematically with sets could be done looking at these axioms. But what this means is that all of mathematics, at least numbers in that sense, all of it is based off of these axioms that whatever Zermelo came up with, he said, wait, these seem like pretty good ones. We can hopefully all agree on these being true. We can accept by faith that it is true, but it's impossible to prove them. So as much as we'd like to prove them, we can't. Same thing with geometry. You have these set of axioms that you have outlined to be true. You can't prove them to be true, but you just simply say, okay, by faith, I just accept, yep, that seems to be good enough for me, and I'm going to do everything mathematically based off of those axioms. So we're going to take a look at what those axioms are to figure out what have you pursued your entire career, your whole college career, basically your whole life. What are you basing that off of? What is the mathematics that you know and love? What are these axioms that have formed everything you know about math?